First law of motion tells us that when a body is acted on by zero net force, it moves with constant velocity and zero acceleration. But what happens when the net force is not zero? So let's consider this figure. At part A, the pack that has zero net force, which means it in equilibrium state. It is constantly moving with a magnitude of v at a straight direction towards to the right. At the second peak, at part B, a constant force was applied at the same direction of the motion that causes for the pack move faster and faster, or simply it's accelerating. In part C, this time the force applied is in opposite direction of the motion. The acceleration is in the same direction as the force. Same with part B and part C, acceleration is in the same direction as the force, in which in part C made the pack move slower and slower. So we conclude that a net force acting on a body causes the body to accelerate in the same direction as the net force. If the magnitude of the net force is constant, then so is the magnitude of the acceleration constant. Many such experiments show that for any given body, the magnitude of the acceleration is directly proportional to the magnitude of the net force acting on the body, which led us to the second law of motion, which states that if a net external force acts on a body, the body accelerates. The direction of acceleration is the same as the direction of the net force. The mass of the body times the acceleration of the body equals the net force vector. So the units for force, mass, and acceleration is given in this table. And the ratio of the magnitude of the net force to the magnitude of the acceleration, A, is constant. So regardless of the magnitude of the net force, we call this ratio the inertial mass, or simply mass of the body. Mass is a quantitative measure of inertia, characterizes the inertia properties of a body, while weight, on the other hand, is a force exerted on a body by the pull of the earth. Mass and weight are related. Bodies having mass also have the large weight, as we'll talk about later in this lesson. So let's have an example problem. A worker applies a constant horizontal force with magnitude 20 Newton in a box with a mass of 40 kg resting on a level floor with negligible friction. So what is the acceleration of the body? So this is our pre-body diagram showing all the forces acting on our body or on our system. So we have here the horizontal force F of 20 Newton. And also, we will represent the vertical forces acting on the box with the weight, which is downward, and the equal reaction of this, which is the normal force directed upward. So this back has no vertical acceleration. So the vertical components of the net force sum to zero. Nevertheless, for completeness, we show the vertical forces acting on the box because it is important that in any system, all the present forces must be represented in our free body diagram to have a better and complete analysis of our problem. So how we're going to solve for this one? So we are looking for the acceleration of the box. So using directly our formula, so we can solve for acceleration, which will equal to the summation of forces, or simply the net force over the mass, or inertial mass, which will give us the value of 0.50 meter per second squared. Now, let's check your understanding. Solve this problem and put your answer in the comment section.